name is Humayun, and in this video I would like to present my project proposal, Learning Cause and Effect of Bias in Decision-Making Process by Machine Learning Algorithms. So before I start, I would like to explain what is AI fairness and where it comes from. Bias, it comes from bias, and bias in data introduce a new term, AI fairness, which basically means fighting against bias and discrimination. It has a long history in philosophy and psychology, and recently in machine learning. However, in order to be able to fight against discrimination and achieve fairness, we should first define the notion of fairness. And philosophy and psychology have tried to define concept of fairness long before computer science started exploring it. The fact that no universal definition of fairness exists shows the difficulty of solving the problem. However, we are tackling with this problem and I would like to study it more deeply. And the questions I would like to face and I'm going to study in this project proposal are how a predictive algorithm can be unfair, how do we specify the degree of fairness, and what does it mean to ensure algorithms act fairly. So in every pipeline of our decision-making process, there is a bias. Bias comes from our external world, from our real world. And then we proceed to data world. Our data, there are three types of bias: historical, representation, and measurement. So historical has already existing bias in the world that has seeped into our data because it was already in the past. And representation bias is a bit different. This happens from way we define a sample from a population to create a data set. For example, the data used to train Amazon's facial recognition was mostly based on white-faced, leading to issue detecting dark-skinned face. And measurement bias is a bias that occurs when choosing or collecting features labels to use in predictive models. Bias also occur in ML process. Evaluation bias occur during model iteration and evaluation, comparing our results to some benchmarks, which is different from a general population, which will be used that a model will predict against for. And aggregation bias occurs during model construction, where distinct populations are inappropriately combined. And the population of interest is heterogeneous, which means with the same features. And lastly, human review. Even if we collect perfect data in these stages, a human review may lead to biasing the data because the human review is based on his or her social bias. And lastly, actions taken depending based on this data. So as a real world example, I would like to show a couple of examples. First is self-driving car, and there is a term AI transparency, where comes from the decision that a car made the decision to turn left. And watermelon, if we show an image to somebody and I ask it, what is it? Most people would say watermelon, but nobody would say red watermelon. However, when I show it this picture, everybody would say yellow, 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 because it's unusual for people to see yellow watermelon. So this is where bias comes from. And these are references I used. Thank you for watching the video.